Hey, this is Contemporary Math, Unit 3A, and we're going to be talking about uses and abuses of percentages. So there's three ways of using percentages to express a fraction, to describe a change, or to compare to something else. The first way is percentages as fractions. So you know that percent means to divide by 100. So p% means p over 100. 3.5% would be 3.5 over 100, and that's how you write it as a decimal. 1/5 is 0.20, which is 20%, 20 over 100. 0.25 is 25 over 100. You guys know all this. This is just review. The second way is to use percents to describe change. So let's say that we say that a town's population has risen from 10,000 a decade ago to 15,000 a day. So we can express the change in population in two ways. The absolute change is 5,000 people, but the relative change in population is 50%. Because if it rose 5,000, 5,000 is 50% of that. So we can say that the population has risen 50%. And that leads us to absolute change and relative change. So here's another example. A company's stock doubled in price from $7 to $14. What were the absolute and relative changes in the stock price? So the absolute change is just the new value minus the reference value. The reference value is what you start with. And that's always just a number. So the absolute change here is $7. And the relative change is listed as a percentage. So you're going to take the new minus the reference value, which is the absolute change, and you're going to divide it by the reference value, what you started with, multiply that by 100. So when we do that, we get 7 over 7 times 100, and it rose 100%. So anytime something doubles, like this one did, we say that it rose 100%, and that's the relative change. Here's another example. You bought a laptop 3 years ago for $1,000. Today it's worth $300. What's the absolute value and the relative change in the laptop's value? So we know that this is depreciated in value, right? So our absolute change is going to be a negative number. It went down $700. Well, I want to know what's negative 7 over what we started with times 100. That's going to equal negative 70%. So your laptop depreciated 70% of its value in 3 years. All right. The third way that we use percentages is for comparisons. So let's say we want to compare the price of a $50,000 Mercedes to the price of a $40,000 Lexus. The difference between the Mercedes and Lexus price, so the absolute change, is $10,000. So the Mercedes costs $10,000 more than the Lexus. I want you to pay attention to how this is written. And we can also express that difference as a percentage of the Lexus price. So $10,000 divided by 40,000 is 25%. So in relative terms, the Mercedes costs 25% more than the Lexus. And because we are comparing to the Lexus price is the reference value. And remember I said pay attention to how this is worded. More than the Lexus. So the Lexus is what we're comparing to, and that's what would go there. So the absolute difference is the compared value minus the reference value. And remember, the reference value is the Lexus, which is 40,000. And then the relative difference, the percent change, is the compared value minus the reference value. In other words, the Mercedes minus the Lexus divided by the Lexus. Okay, here's another example. Okay, so consider a population that triples in size from 200 to 600. There are two equivalent ways to state this change with percentages. So the relative change is the new minus the old divided by the old, or reference value, and we see that it rose 200%. The new population is 200% more than the original population. And then we can also talk about the ratio of the new population to the original. So the new population compared to the original, it's 300%. So the new population is 300% of the original population. So the relative change was 200%, and the new population is 300% of its original. Here's another example for comparisons. The store is having a 25% off sale. How does an item sale price compare to its original price? Well, 25% less than its original price, that means it's 75% of the original, because 75% and whatever the discount is has to equal 100%. So if this were 30% off, you would be paying 70% of the original. Okay, so now we want to talk about percentages of percentages. Suppose a bank increases its mortgage interest rate from 3% to 4%. And it's tempting to say that the interest rate increased by 1%. But remember, the relative change, you're going to take the new value minus the reference and divide it by the reference. So you would end up with 4 minus 3 over 3, which is 1 over 3. If you multiply that by 100, you get 33%. So then the absolute change is 1%, but the relative change is 33%. So we can say at this bank, the mortgage interest rates rose 33%. Here's another example. The rate of e-cigarette usage among middle schoolers, I need to put an S on there, was up 36% to 5.3%. What was the rate of the e-cig use before this increase? Well, I know that the new rate equals 100 plus 36%, because it rose 36% of the previous rate, right? So the previous rate equals the new rate divided by 136%, which is the new rate divided by 1.36. And I know that the new rate is 5.3, so I would divide that by 1.36. And the previous rate then was 3.9%. So let's take a minute here to talk about abuse of percentages. So one way is with shifting reference values. What do we mean by that? Okay, so your employer gets you to agree to a temporary pay cut, promising to give you a 10% pay raise after 6 months. Will that pay raise restore your original salary? Okay, so let's say you were making $500 a week before the cut. So if you took a 10% pay cut on that $500, your new wage is now $450 a week. So in 6 months, you get 10% of this back, and 10%, 450 plus 10% of that is 450 plus 45, which is only $495. You're not back to what you started with. So That's why this is called shifting reference values, because when you took your original pay cut, you took 10% of this amount. When they added 10% back, they were using this as my new reference, the new pay. So shifting reference values, we're using different pay to determine the 10% amount. So that's an abuse of percentages. This is one of my favorite examples in the whole book. So a store advertises that it'll take 150% off the price of a particular item. What should happen when you go to the checkout with a $500 item? Okay, think about this. Is it possible to take more than 150% away from something? So if it was 100% off, this thing's going to be free, right? At 150% off, the store actually owes you 50% of this item. So I would expect at checkout to get some cash, $250 to be exact. So yeah, I would say that the whoever made this advertisement doesn't really know much about percentages. Another abuse of percentages is you don't average percentages. So let's say that you got 80% on test 1 and 70% on test 2. So would the average be 75%? This would be true only if both of these tests had the same amount of questions. In other words, they both have the same reference value. So suppose test 1 only had 10 questions, meaning that you had 8 out of 10 correct, and test 2 had 20, 70% of 20, that means you had 14 out of 20 correct. So the average of these two tests is really 8 plus 14 is 22 for a total of 30 questions. The average is really 73.3%. That's it for 3.A. Your assignment is the quick quiz 3A on page 135. If you have a book at home, know that the answers to the quick quizzes are in the back of the book. But in my experience of looking at those answers, they're not always correct. Just so you know.